All right, guys, this is going to be our part 8, where I go over all of the parts that I missed in the last video. So, starting with the absolute value inequalities, I believe I missed C and D. So to work these really quick, your main goal here is to isolate the absolute value and then go into your positive and negative solution. So the absolute value is already by itself on the left side. So we would go right into our positive 5 and flip the sign. And now we have our negative 5. All right, then we can solve by adding 2 to the other side. Now we have x is less than 7, less than or equal to, and x is greater than or equal to negative 3. Now we put those numbers on our number line. And because it is less than or greater than or equal to, the equal to tells us we need to color in that dot. And then we can either read the inequalities and shade that way or remember the trick. So when we read the inequalities, the first one says we want to shade where x is less than 7. So that would be to the left of 7. And the one on the right says x is greater than negative 3. So again, that would be in the middle. So you can do that, or we can look at the sign. Once the absolute value here is isolated, we can look at the sign and say, okay, well, this is less than. And when we think less than, we think less than. And an and is a conjoining word. So we're going to shade in between when the two are together. So negative 3 and 7. So shading them together. All right, for the next one, we need to subtract 1. And now we have the absolute value of 2x plus 3 is greater than 5. Now we could look at that sign. It's great or. So we're going to say great or. And or means we're shading to the outside, two separate pieces, this or this. Okay. So continuing this out, we have our 2x plus 3 greater than positive 5, and 2x plus 3 is less than negative 5. So on that negative, you got to flip the sign and make it negative. All right, here we have minus 3, 2x is greater than 2, divide by 2, and that leaves us with x is greater than 1. On the left, we subtract 3. Now we have 2x is less than 5, 6, 7, 8, negative 8, divided by 2. So x is less than negative 4 and greater than 1. So again, we're great or, so we're going to shade the outsides, or we can read the inequalities. It says we want to shade where x is greater than 1. So that's going to be shaded above the 1. And we want to shade when x is less than 4. That's going to be everything below the 4. And this time we do not shade the insides of those circles because it is only less than and greater than, no equal to. We only shade the circles when it says equal to. All right, and then I believe I skipped this next section here. Yeah, all right, I love graphing inequalities. I think these are so fun. So let's start out with these. When we graph them, we need them to be in slope-intercept form. Is y equals mx plus b. And just some notes, when we have less than, we shade above. And if it's greater than, we shade, oh, just kidding, I said that backwards. Oops. If it's less than, we shade below. And if it's greater than, we shade above. So that could be either of those. Now, as for the line, if it is less than or greater than, we have a dashed line. And if it's less than or equal to or greater than or equal to, then we have a solid line. All right. Now, the thing about the dash and the solid line, if it's a dashed line, points on the line are not included. Points on the dashed line are not included in the solution. Now with this one, points on the solid line, those are included. And I know that's super messy. That says in the solution. All right, to continue, we need these to be in slope-intercept form as we set up here. So we need to solve for y. So starting with the first one, we have 5x plus 3y is less than 12. Solving for y, we would subtract the 5x to the other side. We're just moving it, so it's not trying to be combined with anybody. It also has an x, and a 5x can't be combined with a plain 12. Next, we will divide by 3. And now that we have y by itself, our slope is negative 5 over 3, and our y-intercept is 4. So graphing that line, we always start with the y-intercept, 1, 2, 3, 4. And our slope goes rise over run. So down 5 and to the right 3. 1, 2, 3, 4, 5, right 3. 1, 2, 3, 4, 5, right 3. And this is just less than, so we're going to have a dash line. Okay. And because it's less than, we would shade everything below. All right, now let's do the other one. We'll use purple. Here we have to add the x to the other side, and we're left with 3y is greater than or equal to x minus 6. Then we could divide by 3. And if I'm moving too fast, pause the video. 1/3 x minus 2. So our slope is 1/3, and our y-intercept is negative 2. So starting with negative 2, slope being 1/3, we're going to go up 3 and right, up 1 and right 3. Okay, it has the line underneath, so less than or equal to means we have a solid line. Now it's greater than, so we're going to shade everything above this line here. And our double shaded area here is where our solutions will be. So any points within that region are solutions. Points along this part of the dashed line are, this part of the solid line are solutions, but points along that red dashed line are not solutions. Okay, let's take a look at the next one. These are already in slope-intercept form, so we can go ahead and plot them. Notice how the second one here does not have an x. That means it is a zero slope. So here, y is less than or equal to 4, so we go on the y, put a dot at 4. It has less than or equal to means a solid line, and it's less than, so we're going to shade everything below that line. All right, now for the other one, we have a y-intercept of 6, and our slope is 5 over 4. So we're going to go 1, 2, 3, 4, 5 up and 4 to the right. Then we'll go back and we'll go the opposite. 5 down and 4 to the left. Now, what is the inequality? It's greater than. So dash line, and we shade above. So again, everything in the double shaded region is where any of our solutions might be. Because, oops, I just a little too much there. So anything along this part of the solid line would be included in our solution, but nothing on the dotted line would be included. All right. Okay, I know I did the matrices. The next part I skipped was on page 6. So we're going to solving quadratic functions on page 6. Right here. Skip this and this. Okay, so it looks like I did this part, so that's good in one of the videos, but I skipped this first problem and I skipped this section here. All right, so doing that, starting with the first problem, what are the solutions to x plus 2 times 3x minus 8? So this is already in factored form. This has already been factored. So what we're going to do is we're going to take each set of parentheses and set it equal to 0, and that's going to give us our x-intercepts. So x plus 3 minus equals 0, that means x is negative 3. And this one we'll add the 8 and then divide by 3. That's going to give us a fraction. X equals 8 over 3. So those are our two x-intercepts. Some other words for x-intercepts: roots, zeros, or solutions. All right, moving on to the second section here. It says greatest common factor. What is the GCF for each expression? Backwards. So what is the greatest common factor of both of these? Well, here we have 4, negative 4, and negative 16. What number are these all divisible by? Yes, they're all divisible by 2. What's the greatest number? It's going to be 4. So if we were to factor out a 4, it means we're dividing everything by 4. And we'd be left with x squared minus x minus 4. So the GCF here is 4. All right, next one we have 6, 9, and 18. What is the largest number they're all divisible by? 3. So when we factor out a 3, we would be left with 2x squared minus 3x minus 4. So our GCF here is 3. All right, let me double check. Nothing else I skipped. Okay. Now, I think I did skip the regression problem, but all you do is follow these directions here. All you have to do is look up the Desmos calculator and type all the information in. When it says write the equation, that doesn't mean write the both, the quadratic and linear. You want to choose which one, which equation has a higher r squared value. Whichever one is higher, that's going to be our better equation. So when it says, what is the approximate time when the rocket reached its maximum height? Well, maximum height, what is the maximum height here? I guess you would look at the graph, because it's probably quadratic. Look at the graph and find the highest point of that graph. What is the max there? Okay, so this is going to be our max. So whatever this number is here of the highest point, look at the x value. What is the x value there? That will give us the time. Okay. And then what is the approximate time when the rocket hit the ground? Well, ground is going to be 0. So you can go look at x is 0. What is y? Okay, and you do have to have this filled out, or you won't get the 5 points. Okay, I think that's everything. Let me know if you have any questions.